So we were team CTD, and then for fun, pH also. This is an instrument that's, oh, sorry. I'm Otis.
I'm Mark.
I'm Megan.
Great. That's Jonah in the photo. CTD is used by people like Noah to measure these qualities of water. This instrument obviously is massive and awesome because they're in an environment a lot different than this lake in Arkansas that we went to. I'll let you do this part.
Right, so basically the premise of the project is that SWEPCO power plant makes the water real hot and maybe changes other properties of the water, and so you can go up to where it's outflowing and measure all of these things and see how they change with depth and with distance from the discharge area. And they didn't seem too worried about what we might find because they let us do it. So
because these instruments are like very readily built, we weren't so concerned about whether or not. The big thing with this was the housing, right? We're going to put a bunch of electronics in water. So the two phases of our build, one is housing and waterproofing everything. So the fundamentals is that it's a 4-inch inner diameter PVC pipe, which can only handle so much depth. But it was fine for us. On one end, we have this flange that the idea was it could be detachable so we could access our instruments if we needed to later. We ended up just sealing it closed anyway because we got really nervous about water getting in. And then the other end, we have this inset plastic, holes drilled in, and that's where the sensors come out. Those are epoxied in, and then silicone around those to help waterproof it. You'll see also that we duct taped a big weight on the side of it to make sure it really got down in the water. That was necessary, but another fun part of the waterproofing is that we filled it with vegetable oil. So this is really heavy because it's full of oil. And the idea with that is it helps with the weight, it helps with the differential stress, so when it drops in the water, it doesn't implode. And it also helpfully slows any leak that is occurring. The water's not going to hit our instrumentation as fast. That was a really cool idea by, I think Blackman, is that you? It's awesome. Sensors, yeah, the whole point is to send sensors in the lake. I put this photo just because it exists and it's us working. All of the sensors that we got worked out of the box pretty much, except for temperature. So, Mark, do you want to talk about how you built the temperature?
Yeah, sure. So the temperature sensor is this metal rod you can see sticking out here. So that is a IC component mounted into this pipe, and then I also did the wiring, and then we put in some epoxy to fix it in place. So yeah, the idea is of course that the metal kind of conducts the heat, and then you would have the sensor as close to the water as possible.
Waterproofing. So this photo, you probably heard us laughing at one point yesterday, the day before. After we fit this end with all the sensors mounted on it onto the pipe, we decided that we were still nervous about waterproofing it, so we took the caulking gun and just flooded the inside with silicone, and someone had to hold it while I stuck my hand in there and was pushing the uncured silicone around all the different ports, and it was
visceral.
Yeah. It's visceral. That's Megan refusing to look at me. I underlined all the different types of things that we use. We were laughing about all the different varieties of plastic that we're just going to chuck into a lake to see whether or not the coal people were lying. It's like, who's the bad guy? I don't know. And it's like as if we actually cared. We sent it down with like masonry twine, you know, that like neon to make sure your bricks are laid flat, like not a load-bearing thing. So we were pretty much just sending a little piece of pollution in there.
Yeah, okay. So as you said, the sensors were kind of straightforward to get up and running, and the data logging also showed you know, that they were kind of active. They reacted to water being there or not there. But the calibration turned out to be quite time-consuming in the end. So what you can see here is for pH, pressure, and temperature, we made like setups before we mounted the devices in to try and get some data points to then later map the data that we collect during the deployments. And they look quite linear here. And one thing that we didn't have time before we went to the lake was also calibrating the conductivity. So that's actually also the reason why this pipe here is glued. So at the bottom here we have the conductivity measurement, and we try to kind of afterwards figure out how we can interpret these values. Yeah.
That's just that.
Ah, yeah, that's
Oh, drone video.
Drone video.
Drone video.
John Leeman has a drone and he likes to use it, so.
He's not afraid. Okay, we can skip through some of the drama.
What?
What?
You want the drama?
What, the drama? Well, you can get drama from here. Oh, it's so cool. So we're boating towards the coal power plant, which you can see back over there. Oh, I think I skipped my favorite part. It's really pretty. It's a really pretty day. We're very, very, very well pleased. Yeah, so we just dropped this off the side of a boat.
Do you know
Yeah.
the depth where?
Yeah, we have a pressure sensor that we could convert to depth. Also, the Kurt has a really fancy radar system on his boat, and so I'll show you in a couple slides, but it's very cool, and you can see depth from that as well. Also, thank you to Kurt for taking us on his boat. Right, so here's a picture of the lake. We took 4 measurements out by the discharge of the power plant in a very nice array. And we also did one last measurement as far away as we could at the dam for sort of a control. And just like the water was, like you could stick your hand in it, it was 10 degrees colder at the dam than it was at the outflow. Next slide, friend. All right, next. So this is just zoomed in a little bit. Yeah, so we started just in case the thing didn't work or there was not the waterproofing wasn't good. We just started at like as close to the outflow as we could, and then we moved out away from it. Next.
Oh, yeah.
It's not that good of a video.
Oh.
Wait, no.
Oh. Really cool. Should we reenact it? We can all get on the table. And we can pretend it's the boat.
Wait, here, yeah, okay. So it'd be like, so this is the boat, and then you just
screen.
Yeah, and you just put it in. And it goes.
Yeah, one thing maybe to say is that putting on weight was good for making it less buoyant going down, but it also made it more difficult to keep it up. I mean, so we manually sunk it down and then tried to pull it up more or less uniformly. But that took like some work to actually.
Did you have like a pulley system? Or?
We had Mark. Fun thing about you have to think about where you're doing your work, right? So once you're on a boat, all you have is what you have on the boat. I really like that twine. This thing is really heavy, and then we strapped a weight to it. We had it on that masonry twine, and then we asked Mark to pull it up from like 20 feet depth.
Up to like 50 feet.
Yeah, up to 50 feet, and he's just slow and steady.
I mean, I like
No
doing
complaints.
it, but it's definitely a bit of a workout.
And then we also had our laptop hooked up to the LabJack, and so we could like see the readouts as we were going, and we could see that they were changing and working, and so that was good. Yeah.
And the weight of your sensor was suspended only with the cable that
No, with like a piece of twine, basically. Like
Yeah.
fishing line.
Okay.
Well, not fishing line,
A bit thicker, but
but not that much.
Yeah,
Yeah.
yeah, that was brutal.
It worked.
I was really worried the twine was gonna snap, and if it did, then we'd be hanging by the cable. The cable is connected to the LabJack, connected to the computer. So I was like death gripping the computer, worried that it would just get like sent in. But it didn't. We're so lucky.
Oh, and then this is the cool radar. So if you look really closely, you can see this like line thing is the instrument, and all of these guys are fish. We can see that the fish were like super interested in our vegetable oil filled plastic tube. Yum.
Yeah. Yeah, the RSV, that red sealant that we used, like, kind of looks like power bait. I don't know if it smells good. They were really into it.
Yeah, so after we did our measurements, mostly this morning we looked at the data. So we have the 4 different sensors. We have pressure, temperature, pH, and conductivity. And one thing that is always nice to look at for these types of profiles is the pressure, because it relates very directly to how deep you are in the water. So here I just took this plot, chopped it up a bit, and stretched it out. So that basically is kind of like the story of our measurements. We started out at the outflow at the river, where it's kind of more shallow. We went down a little bit, up again, then second measurement, third, fourth, and then we went all the way over to the other side of the lake, and that's the last measurement here. And you can see that it was also the deepest measurement that we've taken, I think like 26 feet here, and these are like 10 feet, 23 feet, something like that. But yeah, so the data analysis is a bit more involved than the optimism I brought with me this morning. So we don't really have a lot of actual kind of relating values out yet, so that will take some more time. Yeah, but also, I don't know, I find it quite interesting to see how many small things in the end really go into the conversion from a data that you plot to like an actual value that you say, okay, that must be about that deep. Yeah, but so we have these patterns here, and we can look at the temperature. So for example, here we see that it tends to get colder, which makes sense when you go further away from the outlet of the river, of the power plant. And then when we went all the way to the other end of the lake, it was much colder in that region as well. For the pH values, there is also, looks like there is some data we looked at. But yeah, we would have to like do some basic treatment before and a bit more. And then the conductivity also varies with that, and that's something that I would be quite interested in understanding more, kind of like how much of a difference does it actually make, because I suppose it's all fresh water, and we spent quite some time trying to calibrate that sensor, and it looks like it is actually quite sensitive to so you can see small changes, and to kind of try and understand if that is something coming out of the power plant that makes this vary, or if it's really kind of that the bottom is more saline, so more conductive, you will have to deep seal them than the top of the lake.
Wow. It's a really silly picture we took. Conclusions mostly based off of like, did we get the data? Yes or no? We did. Waterproof, awesome. Look at your data, like give yourself a lot of time to process. Life lesson. Make friends with people who have boats.
Yeah.
Yeah, awesome. Yay. Those are big just in case. Questions?
Did you keep your pressure sensor saturated?
How do we keep our pressure sensor?
Saturated.
It's exposed, so it's this one that's flush here. It's just an open hole, and then it's a diaphragm with a strain gauge on it, right? So just trusted that once it was in the water, it was saturated, I guess. Interesting. Yeah.
How do you think you would go about taking this from something that you're like deploying once off a boat into creating like a permanent monitoring station? Just given that you have to power it in the water.
Well, we were powering it from out of the water.
No, I'm saying, like, how do you think you would, so that you're not just on a boat all the time?
Well, why'd you want to get off the boat? Okay.
Buoys exist.
Yeah,
To
buoys
drop
exist.
something from a buoy.
Yeah. Have a
Yeah.
buoy with a solar.
Cool.
Yeah.
Julia.
So was this just measuring, were y'all doing it primarily for like the bottom of the lake, or, because like when you got it to the bottom, did you like keep it there for a second, or did you just go as far down as you could and then bring it back up, or?
Yeah, it usually stayed at the bottom for some time. Also because we had the radar to see it go down, but also kind of feeling when you have less of a weight on your string was kind of tricky. So it always also, it took a little bit of time anyways to really be sure that we hit the bottom.
So then do you think your data is affected by the probe actually like moving over time versus being at the bottom? Like, do you think the data when you're at the bottom is more accurate than when it's going down, or?
Probably, yeah. I mean, for example, the temperature sensor takes some time to stabilize. I'm not quite sure how quickly they stabilize versus us pulling it out and putting it in again.
Those are definitely like findings from our data that we have not found. You know, it's like once you look at your data and you're like, oh, that went wrong. I could do that better. That needs to be slower. That should be faster. Haven't looked at that yet. Yeah, probably needed to move slower, if anything. One time we pulled up the instrument and it had like a lot of sediment stuck to it, and it didn't seem to be on the sensors, but like maybe it needs to be rinsed between each drop.
Jonah.
So obviously the temperature was pretty different from the intake to closer to the dam. Were there any other sensors that you guys noticed were considerably different from the intake to the dam site?
I wonder.
Yeah, I mean, one other kind of oddity for the pressure analysis is that you can see here that the fifth deployment starts at like a lower value. And one candidate or one explanation could be that the temperature is lower, and that also has an effect on that sensor. But yeah, so that's kind of an obscurity. And then yeah, you can see that we did see different like pH values. I think you can say from looking at this that there is definitely some difference in the data for the conductivity as well.
You might have said this, but the graphs are too tiny for me to see. How long did you leave the sensor in each place?
You can look at the pressure one. You lowered it about this fast. All right.
More or less.
Yeah. And then we got to whatever depth we could, which was either the bottom of the lake or the length of our cord.
Okay.
We
So
were probably at each location for like 5 minutes.
yeah, quick
Yeah, I think that's
minutes.
And yeah, it might have been better to have something to like lower it at a consistent rate and also slower to give things time to equilibrate. But we didn't.
Do you have a blown up version of the temperature?
no.
Okay. So you do see depth change with the temperature in most of them, right? Except up close. Is that the way to interpret that? Like right next to the discharge, the temperature was pretty much the same throughout the depth?
Yeah.
Okay.
Yeah. He said, our tour guide yesterday, I forget his name, sorry. He said this number over and over again for us, 300,000 gallons per minute is the flow rate of that inlet, out, whatever, POV. So yeah, I think that the closer we were to that source, the more consistent that temperature was. I don't understand, again, like haven't spent time with the data, like why did it drop and then squiggle and then come back up? Is this the real data? And this is something funky? Something we didn't do on the first deployment is just put the instrument in the water and let it sit there for a minute. We immediately put it in, we're like, sick, let's lower it. But honestly, it's like, it was early morning, so it was really hot outside. And then it's like, oh, it's gonna be really refreshing around the lake. You stick your hand in the lake and it's almost hotter in the lake. So it was in open air, which again, like it's not fully coupled, but I do think temperature's okay.
Good.
Yeah.
So did you basically do one trial at each location?
Mm-hmm.
Okay.
That temperature's a degree Celsius, right?
Mm-hmm.
Yeah. It was really hot.
100?
Mhm.
Yeah.
100 degrees
Wait,
Celsius is
wait.
boiling.
No, it was
I am concerned for your head.
Yeah, it was like,
Wait.
this is Fahrenheit, yeah.
It's Fahrenheit.
I made this plot like 7 seconds ago. Yeah, that's Fahrenheit. Yeah. Sorry, we're working in freedom.
It's really hot.
Yeah, sorry.
No,
Welcome to Mars.
as I said, this morning we jumped right into the middle of the data analysis because we didn't have a lot of time set and going from like top to bottom. So.
Perfect.
Yeah, it's kind of hard to like calibrate and analyze 4 separate quantities in, you know, the 2 hours that we had. But so, I don't know, work harder next time.
Yeah. Yes, obviously. I love these questions. The tape on the outside is for swag.
For vibes.
Yeah, for vibes. It was also nice to be able to see our instrument as it approached the surface of the water, but honestly, that was like a second thought. The first thought was just vibes. Yeah.
Well, it's
giving
also the
all of
colors of Leeman, right?
We want to make sure that if we littered it, it would be their fault.